Good morning everyone, my name is Fahad and today we'll be talking about Kotlin, an introduction to Kotlin, a powerful Java successor programming language. First of all, let's talk about why we would choose Kotlin over any other programming language and specifically Java. First of all, adopting Kotlin is easy relatively to Java, and Kotlin also is fully compatible with Java, in which you can add Java code to your Kotlin program using the Java tag. Also, Kotlin has a strong community since it was developed by Google, and also Kotlin suits for multi-platform development using the KMM or the Kotlin multi-platform. Let's talk now about data abstraction. In Kotlin, we can achieve data abstraction through the use of classes and objects. By abstracting data, we can encapsulate the implementation details and expose only the necessary information outside to the outside scope. Variables are used to store and manipulate data in a program. They hold values that can be modified during the execution of the program. And in Kotlin, variables are declared using the var or val keyword, in which the var keyword denotes a mutable variable, and the val denotes an immutable variable. So if you want to change a value over time or during the execution of the program, you use the var keyword, and otherwise we'll use the val for static values. Assignments involve assigning values to variables using the assignment operator, and scope defines the visibility and lifetime of variables within a program. Now let's talk about the primitive data type and arithmetic expressions. The primitive data type in Kotlin represent basic types of data such as integers, real numbers, etc., characters, boolean. And Kotlin provides a various primitive data type including int for integers, double for double precision, and floating point numbers, and char for characters, and boolean for boolean values. Arithmetic expressions involve performing mathematical operations on primitive data type. For type conversion, the type conversion allows us to convert values from one data type to another in Kotlin, like you can switch between integer to double and vice versa. And Kotlin provides built-in functions and operators for type conversion. The char data type represents individual characters, while the string data type represents a sequence of characters. And we will see an examples after we done discussing with the slides. For advanced and abstract data type, in Kotlin provides powerful abstractions for organizing and manipulating complex data structures. These data types include arrays, records, tables, lists, trees, graphs, and more. They offer specialized functionalities and operations tailored to specific data organization and manipulation requirements. For pointer and reference types, pointer and reference types in Kotlin are used to store memory address for reference to objects. Pointers allow direct manipulation of memory locations, while references enable indirect access to objects. And Kotlin abstracts away explicit pointer manipulation, providing safer and more convenient reference-based programming. The logical expressions in Kotlin involve evaluating conditions based on logical operators and/or not. Conditional selection statements like if, else, and switch allow branching based on logical conditions, and repetition and loop statements like while and do while recursion enable executing code repeatedly. Function calls in Kotlin allow us to encapsulate reusable blocks of code and perform specific tasks. Function definition involves specifying the function name, parameters, return type, and code to be executed. Also, they are made to execute the code within the function and obtain the result. Kotlin also uses pass by value for function calls, but there are some nuances with regard to pass by reference. So to test Kotlin and to develop Kotlin in a Kotlin programming language, the best IDE that I recommend is IntelliJ. So head on to Google and write down IntelliJ. You'll access the IntelliJ IDEA website from JetBrains. They're a leading company in developing IDEs for developers. You can press the download button right over here, There's a free version, and there's also a better version if you can access it if you're university students via your university email. So click download, and the download will start. I will cancel since I already downloaded, and you, it's just a couple of next buttons and you can successfully install the IDE and start developing in Kotlin. Okay everyone, let's start doing the examples for what we discussed in the slides. First of all, let's talk about the variables and assignments and scope. Here we declare two different variables, one using the var keyword and the other is using the val keyword. As we discussed, the variable can be modified while the val keyword cannot be modified. In this line, we modify the variable age to 30 instead of 25 to update its value. If we try to do the same thing with the name and decide to declare another value to it, it will give an error and it say val cannot be reassigned, and it will suggest you to change it to var. Now we will print the values stored in the variables that we declared before, the name and the age. Let's try to run using the main function. And as you see, it says name John, age 30, and here we are using an if statement to check if the age is more than or equal 18. It will also print another additional statement that says the status is an adult. Now let's talk about the primitive data type and give it an example. Here we declare multiple variables like age, salary, grade, and is students, each of different data type. The age is an integer, the salary is a double value, the grade is a character value, and is student is a boolean, and it's assigned to true. Here we're doing some arithmetic expressions like the summation, difference, the product, and the quotient and the remainder. After we're doing these arithmetic expressions, we're using the print statement, print line statement to see the variables, the values stored in our variables. Also, the print, you can use the print variable name and class.simple name to also check the type of the variable that you have. Let's see what we get after running this program. Now the variables each are printed on the screen, and also we decide to check three different variables types, which is the sum, grade, and is students. As you can see here, the sum is an integer value, the grade is a character value, and the is student is a boolean value. You can see here that we did some arithmetic expressions and saw how we can print it on the screen using the print statement, and also use the class simple name to print its type. For the type conversion, we have here the number variable. It's a number. It's assigned the value of 10, and here we declare another value named text. It's type string, and we will use the same variable number, but we will add the keyword toString, which is a built-in function that modifies and converts the type of integer to string. We will do the same thing with the double, and we will change it to integer. We will use the toInt keyword, and also here we will declare the character capital A and use value Unicode value, an integer, to change the letter to int function. We have a unique example here where if we modify the character to an integer, of course A is not an integer, so it will show the Unicode value that's stored in the memory location in the IDE. We declare some strings here, hello and John Doe, and after running the main function. You can see here that um, this 10 is actually not an integer, it's a string, because we use the toString function keyword, and the double, it was 9.99, and now the quantity is only 9 since it only took the integer value of the variable price. For the character data type, after converting it to integer, it shows the Unicode value and not a capital A. So in the memory location address 65 is allocated to the capital A letter, and we use some print statements to print each of the values that we modified. I hope this was clear and easy examples, and thank you.
Hello everyone, this is Abdullah Adawi, and I will be guiding you through the next couple of topics. I will be explaining two sections. The first one will be a continuation of the data abstraction part, including arrays, lists, and sets. The second section is control abstraction, and that includes if statements, loops, and functions. Data abstraction. In this section, I will explain to you how to make advanced data types like arrays, lists, and sets. The first data type, array. So arrays are ordered collection of elements of the same type. That means you cannot store different data types in the same array. For instance, you cannot store an integer and a string in the same array. To make an array, first you should make a variable, say numbers, and then you decide what is the type of the array you want, whether it's an integer array, string array, etc. In this example, I will make a simple array of integers. So let's say int array of 1, 2, 3, 4, 5. That's an array of 5 integers. Notice that arrays in Kotlin are 0 indexed, which means that if you want to access the first element, you can access it by typing 0. So let's access the first element, println numbers 0. That will print the first element, which is 1. So let's see. The compiler prints 1, which is the first element. That's it for the arrays. Lists. Lists are similar to the arrays. They are also ordered collection of elements. However, lists allow you to store different data types within one list. So to make a list similar to the array, you have a variable. Then let's say random list, that's the name of that list. Then we make the list here, let's say list of, we can put here any data type we want. So let's say 1, then we'll put an integer and a string cheese. We can also put a float in here. Because lists are also ordered, we can access any element by its index. So let's say println random list 1. When we type 1, we will not get 1, we will get the second element, which is cheese, because the first element is 0, second element will be 1. Say here, we got cheese. Lists are immutable, which means that you cannot edit them. However, you can make them mutable by typing here mutable. Now you can edit the list. You can add, you can remove. Let's add an element, random list. Let's add X. Then let's add again. Four. Now, if we display the whole list, we will get the list after we add eggs and 4, which is 1 cheese, 2 eggs, 4. You can also delete an element let's delete cheese and then print the list after we delete cheese. Notice that cheese has been deleted. And that's it for the lists. Sets. So sets are unordered collection of unique elements, which means that you cannot have the same value more than once in a set. So let's make a set variable unique set equal to set of one again cheese 3.33. Now, because sets are unordered, you cannot access an element by its index. So you have to print the whole set to display it. So let's print the set, one cheese 3.33. Now, if I made a set with duplicates values, when you run the code, the compiler will automatically delete the duplicates values and keep the one instance only to keep the list unique. So let's make duplicates here. So we entered one here. So let's enter one again, entered one again, entered 3 and 3 and 3. So you have 3 ones, you have 3 threes. Now, if we print the set, the compiler will delete the duplicates. As you can see, you have only 1, 1, and 1, 3, despite that we added 2 additional ones and 2 additional 3. That's it for the sets. So logical expressions. Logical expressions combine Boolean values, true or false, using operators to form a new Boolean value. These operators allow you to control the flow of your program based on certain conditions, and they are and or not. So let's make a simple example. Let's say age variable age equal to, let's say 19. So make another variable as license equal to true. Then let's make a third variable that will combine two statements. Let's say can drive, and we can make a logical expression by saying age bigger than 18 and has license. Now, if this expression is true, can drive will store true in it. So let's print can drive and see what is stored in it. It is true because age is bigger than 18, which is 19, and has license is true. So true and true will be resolved to be a true. However, if we make one of them to be false, so let's make it the age is 16, so the age is not bigger than 18. So this expression will be false and this will be true. If you put and between them, the whole expression will be false. So let's try again. Let's see. We got false. That's it for the logical expressions. If statements. If statements are the most basic conditional statement. It checks a condition and executes a code block if the condition is true. So let's make a variable grade, for example. Let's make it 91. Now we will make an if statement. So say if grade is bigger than 90, then we will print excellent. Now, if we run the code, the compiler will check if the grade is bigger than 90, which it is, and then we'll execute the block in here. So in this case, the code, the print will run and type excellent. Now we can add an else in case this block doesn't execute, then the code in else will execute instead. So let's say print len. Very good. And then let's make the grade 80, which is less than 90. So this block won't be executed. See the compiler, it skips this block and goes directly in here because the condition is not true. Now you can add another else if. So if you want to have multiple grades, so else if grade is bigger than 80, you will type very good. Then you can add another one, else if grade bigger than 70, print len, let's say good. Then you will have another else if all of the above is false. We'll just print len, not good. And let's make the grade to be 71. So now when we run the code, we'll get good. What it does, what the compiler does, it will compare grade with 90. If it's not true, it will go to the next else if. If it's less than 80, it will go to the next. If it's this true, it will compile and run this block. In this case, we got good. And also if we say 60, it will skip all of it and go to the else directly, which is not good. That's it for if statements. For loops. For loops allows you to execute a code block repeatedly for a set number of iterations. So let's make a simple for loop. Say for I in 1 dot dot, which means 2. Let's say 6. Then we will make a block of code. We will print hello. So now what will this block do? It will iterate from 1 to 6. So it will execute 6 times the println hello. So let's run the code and see. We got hello 6 times. Now we can use the I to know which iteration we are in. So let's say print when I. So now if you run the code, we'll get the numbers from 1 to 6, as you can see. That's it for the for loops. While loops. While loops gives you the ability to continue execution as long as a condition remains true. So for example, let's make a variable counter equal to 0. Let's make a while. Then have a condition like an if statement. Let's say if the counter is less than 10, then execute. So let's print counter. So if we print counter here, without putting counter plus plus, which will increase the counter by 1 every iteration, the while will go to infinity. It will execute infinitely. So let's see if we do it. We'll get here the number 0 and here infinite. Look at that. And that's a problem. So to solve this problem, we should add counter plus plus to control the number of counters. So what will this do? It will add 1 to the counter each iteration, and that will be from 0 until 9. That's how many times it will be executed. Now, if we run the code, we'll get the numbers from 0 to 9. As you can see here, 0 till 9. That's it for the while loops. Functions. Functions are reusable blocks of code that perform specific tasks. To make and use a function. First, you have to define a function. So let's say, for example, like function greet. When you make a function, you can pass parameters. So let's pass a string in here. Let's say name string. Then let's make the block. And this function, we will just print hello and the name that we passed in here. So now to use this function, we have to call it from the main function. So let's call the function, let's say greet, which is the name of the function. And then we will pass the name that we specify in here. So let's put my name, Abdullah, in here. So now if we execute the code, this is a call to the function in here. Once you call it, the compiler will go here, put the name as Abdullah, and then println hello Abdullah. So let's see. As you can see, hello Abdullah. That's it for the function. Recursion. Recursion is a programming technique where a function calls itself. This might sound confusing at first, but it can be a powerful tool for solving problems that can be broken down into smaller, similar subproblems. So a recursive function has two key parts. The first one is the base case, and the second one is the recursive call. So the base case is a simple condition that stops the recursion call and provides the final result. And the recursive call is where the function calls itself with a modified version of the original problem. And usually it is a smaller version of the problem. So I've made here a recursion function that just prints hello. The parameter is just an integer n. So what will this function do? It will first check if the n is equal to 0. If it's equal to 0, then it will stop the function. Otherwise, it will just print hello and then call itself, but with a reduced number of n's. So if you pass a 1 in here, it will go to here, reduce it to 0, and then call it again, and then it will return nothing. So let's, for instance, here, let's pass 4. And if we run the code, we'll get hello 4 times. So that's that means print hello calls itself 4 times. And the fifth, it's just shut off because the n is equal to 0. And that's it for the recursion.
Now we're going to talk about the advanced Kotlin concepts. We're starting with the programming paradigm supported by Kotlin. We have the object-oriented programming, and also one of them is the functional programming. Object-oriented programming, or OOP, is basically a paradigm that uses objects to design applications and computer programs. It utilizes several concepts that we're going to talk about right now. First thing is the classes and objects. So we have, so in Kotlin, a class is a blueprint for creating objects. So an object is basically an instance of a class containing both the data that are attributes and methods, for example, functions or procedures. Also, in Kotlin, classes are declared using the class keywords. So here's an example of a code of a simple class. So we have class called car with its variables, and we have a creation of the object of the class. The next concept is encapsulation. So this principle is about keeping the internal state of an object hidden from outside. So in Kotlin, this is achieved through visibility modifiers like private, protected, which restrict access to the object's components. Here is an example. As you can see, we declare the class person, and we have the variable as a private, which is age, and then we have to use, or we had to use a function that is getAge, so that we can access this private property. So as you can see, then we declare an object of the class val person, and then we use the get age so that we can print the variable age. The third concept is actually inheritance. So in Kotlin, inheritance is basically like allowing a new class to inherit properties and functions from an already existing class. So here we use the open keyword before the class keyword to declare a class that can be inherited, while we use the column symbol to extend the class, the other class. So here we have the example open class vehicle, so that this class can be inherited, and then we use the a class by column vehicle2, so this is extension, and then after we use the object of the bike class, we use the variable wheels from the first class, as you can see. Last thing in OOP that we're going to talk about is polymorphism. Polymorphism, is allowing objects to be treated as instances of their parent class rather than their actual class. So here in Kotlin we use the word overriding with the method, and also overloading. Okay, so here in the example we use overriding. As you can see, we have two classes, animal and dog, and dog class is basically extended by the animal class, and we use the override to get the sound function from the first class. So as you can see at the end, we declare the object of that second class, and we use the function of the first class easily. The second paradigm we have is actually functional programming, FP. So it's basically a style of building the structure and elements of computer programs that treats computation as the evaluation of the mathematical functions. So here we have the higher order functions, lazy evaluation, first class functions. For the higher order functions, these are functions that take other functions as parameters or return them as results. So Kotlin supports higher order functions natively, and then we move to the lazy evaluation. It's provided to delay the computation of a value until it's actually needed, which can improve performance for expensive operations. Last but not least, first class functions. Kotlin treats functions as first class citizens, meaning you can store them in variables, pass them as arguments, or return them from other functions. Here are simple examples of each one of these. You can look at them, and inshallah you're gonna understand the concepts. Next advanced concept is concurrency. So we have two main things to understand: threads and coroutines. For the threads, it's basically a traditional way of managing concurrent executions in the programming language like Kotlin, but it's also similar to Java threads in this case. For the coroutines, it's a feature that provides a way to write asynchronous code in a sequential manner. So coroutines are lightweight and efficient compared to threads. These are some code examples, simple ones for threads and coroutines. We have for the threads, we use the word threads with the T capital, and then we use thread.start to run the thing in a thread. And we have the coroutines. As you can see, we added the delay and so on. There are some more Kotlin features, but these should be specific for Kotlin. We have firstly the null safety. So It's a Kotlin's type system that is designed to eliminate the null pointer exceptions by incorporating inherent null safety checks. The next thing is extension functions. So these functions allow you to extend a class with a new functionality without having to inherit from the class. The third thing is delegation. So Kotlin supports the delegation pattern, which allows you to use composition to achieve code reuse instead of inheritance. Now, as examples of every one of these features, for the null safety, as you can see, we use the question mark symbol here to have like a safe call, and then the extension functions, as you can see, we use it to add like the exclamation mark, and we have it. Next is delegation. So here we have the code sample of delegation concept. So here first we have the interface base called base. The interface basically it contains a number of abstract methods. So here we have the print method, sorry, method or function, and then we have the class base IMPL that has an x as a variable, and we have inside it a function that is use the function print from the interface base. And then we have the derived class that is also use the base extension. And then, as you can see at the end, we have an object of the class base IMPL with 10 as a variable. And then once we use the derived class with passing the variable or the instance object of the base IMPL, and we use the print, the 10 is a print successfully. Now we have a very quick quiz for you. Let's jump on. We have the first question as what keyword in Kotlin is used to declare a class that cannot be inherited? And of course the correct answer is final. Next question is which features of Kotlin helps in preventing null pointer exceptions? Of course the answer is null safety operators. Now in Kotlin, what is coroutine? The answer is a concurrency tool. Now, which of the following is a higher order function in Kotlin? It's an apply function. Now we have the last question. What's the output of the following code? Of course, it is B. At the end of this tutorial, we have these some references you can check out.